This is problem 67 in chapter 8. It's the one with the 2 quarters. And we're trying to figure out when this quarter goes around, all the way around, how many revolutions it will make. So it's going to, in terms of going around the other quarter, it goes around once. But then how many times does this thing spin as it does that if it doesn't slip? It's important that it doesn't slip so that we can use the result of the prior video that you may have watched about linear velocity being the same thing as tangential velocity, or those distances being the same. So if you're not okay that d equals s, you should watch the prior video. So our arc length will equal our distance that the center of this quarter travels, and that's we're gonna set those two equal each other. So what do I mean? If we put a dot right here, we talk about how far it goes around, its distance it travels around one time for that path with the black dotted line will be equal to whatever s is as these two come in contact as it rolls along here. Oftentimes we use that arc length where it makes contact, like from here to wherever it goes to equal stuff going left to right, but we still can relate this to the center of this object moving around. So it is that same idea. It's just instead of moving in a straight line, we've got this center of mass moving around the other quarter. Well, to get your head wrapped around that it's not going to be 1, because it's not. Otherwise, it'd be a pretty boring question. It might still be a boring question, but at least the result's a little bit unexpected. I've got 2 quarters here, and I'm gonna create the problem. I'm gonna hold this one down and make this one rotate. Oh, and notice before you watch this, we've got the head up right here. So I'm gonna base it on how many times this rotates like this as it goes around the other circle, based on the top of his head as I look at this. So we're gonna start to roll it. Try to be careful. Whoops, we had a little bit of slipping there. That messes it up, so I might be a little bit off now. But it looks like when we get down here, pretty close to halfway, there's a little bit of slippage. Remember, there's none of that in this problem. It looks like we're halfway around, and he's already made 1 revolution. So I'm going to keep going now. Whoops, I had a little bit of slippage there as well. But it's going to be pretty darn close. Oh, and then I had some slippage there at the end. I apologize. So we're a little bit off at the end, but when we're back around, it's about 2 revolutions. So this thing spun around twice as it went around another quarter 1 time. So we already know the answer just based on grabbing a couple quarters and seeing how this works. Again, it's a little bit off because we have the slipping, and these results that I'm going to use assumes that this quarter does not slip as it's rotating around the other quarter. Now, why is it 2 revolutions? Got to give that back to the librarian. Let's put that over there. Okay. Why is it 2 revolutions? Well, we got to get an expression for d, for how far this quarter went, like just good old how far, just regular old distance, nothing here with angular or arc length or any of that. What's it carving out? It's carving out a circle as it goes around. What's the distance around a circle 1 time? 2 pi and then r, whatever the radius of that circle is. I put parentheses because I want to talk about what r is. If we're given defining the radius of the quarter is r, and if you look at this picture when you draw it accurately, and they gave you the picture to help with this, you'll see there's an r here, and then there's another r here for the circle that it's carving out. So that means we have a d of 2 pi times 2r. So we're applying that idea of circumference of a circle because we're going around 1 time. This is all based on going around 1 time. So there's one of our equations. The other equation we're going to need is what about the arc length? What about that s value as it goes around? Well, what is arc length equal to? We're going to have r theta. Okay, so we're going to have r theta, and that'll be our arc length. That's back from our chapter 8 stuff. R theta, whatever the radius is, times theta of this quarter right here. We're talking about the r there. So that's it. It's s equals r theta. That is the right r because this is the circle that, excuse me, the circle. This is the quarter that's doing the spinning. It's this radius times whatever angle we move through. Now, we set them equal to each other and we see what we get. So 2 pi, oh, and since we're using this equation where we do r theta, we are dealing now with radians. So I'm going to get an answer in radians, and then since I want revolutions, we'll do a conversion at the end. But when I use this, I am talking in radians. So I have 2 pi times 2r equals, I'm just doing d equals s, equals r theta. And good news, we didn't need to know the radius of the quarter. So the radius of the quarter did not matter, which means If you do this for 2 pennies, it should work out the same, or 2 nickels, or 2 dimes, or any 2 spheres that have the same, or any 2 circles that have the same R. Okay. And now we'll go ahead and get our theta. Theta will equal 4 pi. And then we'll convert, because we don't want it in terms of radians, because right now this is 4 pi, this is radians, which is a label again, and not a unit. Okay, this is just how many times it went around. How many times? 4 pi radians. Well, we don't want how many radians, we want how many revolutions. And we're already expecting an answer of 2 revolutions, so now you can probably see it. We just convert. So we have 4 pi radians, and we've got 1 revolution, 1 rev per 2 pi, because 2 pi, remember, is going around 1 time for circles. So 2 pi radians, the radians will cancel out, and we'll get 4 divided by 2, or 2 revolutions. The same result that we expected when we went ahead and did the experiment. For bonus, if you'd like, if you're watching this video and you want to do your own quick video with other coins or circles, if you send me the link, I'll give you 5 points of bonus. That's it.